Right, I'm just going to cover function notation. And don't overcomplicate this. It's just kind of how we write the function equations. Imagine we have this from an earlier section. Okay, so here we go. So y equals 2x plus 3. Right, so a little input output. Remember, input is x, the answer, the output is going to be y. So what I'm saying here is when x is 2, so I'll put 2 right there. Okay, when x is 2, 2 times 2 is 4 plus 3, y is 7. Okay, we've done that before. Now look at this. I'm going to write it in function notation. Now you can just think of this as a y if you want to. F of x equals 2x plus 3. Okay, 2x plus 3. Now what I'm going to say here, what I'm going to write is this. Okay, this here, here's the x. Okay, well it's because the equations in terms of x. If I write this, watch this. F of 2. If I say f of 2 equals 7, that's what I'm kind of saying. This is function notation. Okay, what we're saying here is I've replaced the x, which was here it is, okay, right here. If I replace the x with a 2, the answer will be 7. Okay, now this is just function notation. Don't overcomplicate it. If you can still think of y equals, but now call it f of x equals f of x, and there's some kind of things down here below. Let's have a look at this. So remember, on the previous video, I'd kind of done an equation for averages. Remember, we're trying to average our grade based on what the 5th test would be. We knew what the first 4 tests were. Okay, the first 4 tests, remember, I think added up to 335. Then, when we added another score, which they said was S, and divided it by 5, we would get, okay, the average. Okay, the average equals. Now for this, all they're saying is, okay, let's do this. A of S equals. In other words, if I replace, okay, this here with a number, okay, I will get my average. Okay, so right now it's S because the equation is in terms of S. What we're saying is this. If I can go back and think, okay, let's have a look at this. Supposing I do what is A of 100. In other words, I just got 100% on my last test. Okay, that means I'm going to put 100 right here where the S is, because again, look, this was an S. Here it is over here, but I've replaced it with 100. Okay, let's replace the equation with 100. Okay, so if I put 100 there, I'm going to have not 335, but 435. Okay. Again, I'm just putting 100 into the equation like I did on the last video. This is no different. We had this when the last test was 100. And I divide by 5. Okay, I'll get a calculator out for that. Right, so what's 435 divided by 5? It equals, it was 87. I can't remember that from when we did this. So what I'm saying is A of 100, A of 100, okay. It's like saying A of S, F of X. I know it's like different letters. A of 100 is 87. The average for when I score 100 on the last test is 87. That's what that's saying there. Okay, when I put 100 into this equation where the S was, I'll get 87 out. Okay, so look at some of the other ones. Okay, I think we've done that. Let's have a look at some of the questions. Right, okay, now look, here it is. Look at this. Here's a function right here, written in function notation. But again, you can still kind of think of it as y equals x squared plus 3. Okay, you can still kind of think of that. It still is that. You know, what's the answer? What's y when x equals whatever? Okay. Now they're saying, okay, let's try. Here we go. If x equals 4, if x equals 4, and I put it right here, okay, where the x is, and I square it, I'll get 16. When I add a 3, I'll get 19. That's why they have here as an ordered pair. When x is 4. Y equals 19. But what we're saying here is also f of 4, I'm replacing the x with a 4, I will get 19. Okay, that's it, because there we go, here's the x right here. Well, no, I'm replacing it with a 4. So I'm saying instead of f of x, say, okay, what's f of 4? I'll put 4 there, I'll get 19 out. So again, you know, letters are all over the place here. Look at some down here. I mean, look at h of a, okay? I know most of the time you'll see a lot of f of x. That's the classic function notation, I guess, f for function, okay? And we always tend to write the equations in terms of x. So I'll just write another one, something like this, okay? You know, okay, when I replace an x with a 2, in other words, what's f of 2? I will get 5, won't I? Okay, 2 plus 3 is 5. So that's kind of now the function name for here. Okay, this is not too important, I think, but that's the function name, and of course this is the input variable. Now the classic really is cost, and if I find a cost equation, let's look somewhere ahead of here. So if I can look at anything for cost, let's just keep flicking through. Okay, here we go. The cost. Now here's a good example, good activity here. The cost of a history club is it's $78 for transportation plus a $2 admission charge for each student. In other words, right, watch this. Normally I would say, okay, the output, whatever the cost is, the output is, right, it's $2 per student plus a $78 transportation fee. We're going to pay this constant of $78 for the bus, whatever it is, but then it's $2 for every student. That would be the equation. But all I'm going to do now is write this. So again, a little eraser, erase this, and write this. C of x. Okay, that's it. That's all I've done. This is a cost equation, so I'm going to call it C. The cost is. Alright? So, if we look down here, if I can keep that up there, this here, right, if the number of students is 10, what I'm saying is this. C of 10 equals what? And that's what I'm going to put right here. Okay, the cost for 10 students. I'm replacing the x right here with a 10, because there it is right there as well. So I put 10 there. Right, what's 2 times 10 is 20, plus 78, it's 98. Okay, woo, finishing off 98. Okay, further down. Okay, now look at this. Okay, so we've created it. Use n to represent the number of students. I used x. Okay, so if we do it with an n, no big deal. Okay, c of n. Okay, not c of x, because we're going to use n in the equation. You can use whatever letter you want. Okay, so I'll write it like this instead, and that's just the same as the above one, but with an n there instead of an x. Okay, same as that one. But of course, if I've got x in the equation, then x has to be in that little parenthesis next to the c. Okay, there we go. Now just think about this. This is not a multiplication thing, okay? You know, it's next to the parenthesis. This is just what's c of n, all right? C of n. It's a function notation. You can still think of it as y equals this, okay? What's the answer when n equals 15, for instance, okay? So, if it is 15 students, okay? So again, what I'm saying is the next one. What's going to be the resulting cost? The c. Right, I would do, okay, what's c of 15? What's the cost for 15 students? Okay, right, okay, so again, put it right here, because I've replaced that with 15, same letter, okay. 2 times 15 is 30, plus 78 is 108, which is exactly what this is saying, alright, okay. So, it was 108 for 15 students. And you can do whatever you want. Determine C of 37. Look at this one. Oh, let's have a look at this. Is C of 24 126? I'll write the equation again. Remember, the cost, number of students, is $2 per student plus $78 of transportation. So, if I put, can you see, if I put 24 here, alright, in other words, C of 24, that means I'm replacing the n right here with 24. It's 2 times 24, 48, plus 78, yes, is 126. Now if I wrote that as an ordered pair, I'd write this. Here's the input, the x, here's the output, the y. And still think about using these, okay? There you go, that is it as an ordered pair, okay? Just as if you were to graph it. I think we'll call it halt on that one. Okay, so that's really what function notation is, okay? You can still kind of think of it as a y equals, but again, the classic is f of x. Here we're using c of n because we're thinking, okay, it's cost, and let's use n in the equation instead of x. So many ways you can write it, but that is just using function notation, okay? Get used to function notation.